Hello, in this video, I will explain to you on how to solve this problem. Number 23, using Kirchhoff's rules, find the current in each resistor shown in figure P18.23 and B, find the potential difference between point C and F. Okay, first we need to label all the voltage and the current for each component in the circuit. The easy one is the battery here, because the long one here has to be positive terminal and then the short one is negative terminal. Let's label all for the battery here. So this one is positive, this one is negative, and this one is positive, and this one is also negative. Good. Now let's label the current that passed through that battery. Okay, I'm assuming that this battery giving current to the circuit here, so I assume that it will goes up like this. Let's name this current I1 like this, and consequently this will also I1, right? Because this will be in series, so I1 will flows here and then goes there and goes there, right? So that is I1. And the same here for I2. I will assume this one here is I2. And so this one here that passed through this 3 kilo ohm resistor is also I2. Good. And then let's label also this. This will be giving current there. So I label this as I3. And eventually it will turn left here. And this is also I3 because it is in series with this one, right? Good. Now we have labeled all the currents in the circuit. And then we need to label the voltage in the resistor. For this one, I use this convention. Where the current comes from is the positive side. And where the current goes to is the negative side. Okay, let's do that for all the resistors. So where the current comes from is positive. Where the current goes to is negative. And again, we have this one. Where the current comes from is positive. And where the current goes is negative. And then we need to do the KCL, the junction rule, or the KCL, yes, the Kirchhoff current law at this point here. Let's do the Kirchhoff junction rule. Okay, what does the junction rule say? It is said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, the sum of the current that goes in will equal to the sum of the current that goes out. And if you see here to the point C, I1 is going into point C. So let's write that. So I will have I1 on the left hand side. And then I2 also going into node C. So I will have plus I2. And then here I3 also goes into node C. So I will have plus I3. And all of that will equal to 0. And I think we can isolate one of them, right? So we can have I1 here. Okay, so let's have I1. I1 is equal to minus I2 minus I3. And we can save that and it will be very useful later. Good. Now let's see what can we have here from this loop. Okay, now let's name this loop here. Let's use this loop here as loop 1. And this loop here is loop 2. Now let's do the Kirchhoff loop rule at loop 1. Loop rule at loop 1. Okay, the loop rule said that the sum of the voltage in a loop will equal to 0. And then the sign will be very important. That is why I label all the components in the circuit here. Now let's start from this battery here. The loop here entering from the negative terminal. So I will have negative sign. Okay, and we have already the voltage here, which is 70 volt. So I will have minus 70. Minus 70. Then let's move on to this component here. And this loop here entering from the positive terminal. So I will have plus. And then the voltage here is 60 volt. Good. So I will have 60. Then what else can we have here? We move on to this resistor here. And here the loop enter into negative terminal. So we will have negative sign here. But then this is resistance, 3 kilo ohm. To get the voltage, we need to multiply it by the current. So I will have 3I2. Right? Because 3 kilo ohm multiplied by I2 will be the voltage. However, I2 has to be in milliampere because this is in kilo ohm. But that is not a problem. Let's move on here. So we move on to this resistor here. And the loop entering from the positive terminal. So we will have positive sign here, and we will have 2 kilo ohm there. So I'll have 2. But then we have I1, right? So we will have I1 here. And then I think all of that will equal to 0. Good. What else that we can have here? I think nothing. So let's just write this one, 2I1, and then minus 3I2, and then we'll have minus 70 plus 60, that will be minus 10, and that will equal to 10 here. Good. And then what else that we can have? We can have this I1 here is minus I2 minus I3. Okay, now let's plug that in. So I will have I1 is minus I2 minus I3. Okay, and then minus 3I2. That will equal to 10. And then we'll have minus 2I2 minus 2I3. And then minus 3I2. And that will equal to 10. And now we will have minus 5I2 minus 2I3. And that will equal to 10. Okay. Okay, we have another loop to take care of. Let's erase this, and what can we do there? Okay, so far we get these two equations. We still need to do analysis on this loop rule at loop 2. Okay, let's do that. Loop rule at loop 2. And again, this time we will have the sum of the voltage in that loop will equal to 0. Good. Now let's see. Let's start from this battery here. The loop here is entering from the negative terminal, right? Loop 2 entering E2 from the negative terminal. So we will have negative sign. We have minus, and the voltage will be 60. Good. And then here we enter into this 4 kilo ohm resistor from the negative terminal. Again, we will have negative sign. Okay, so I have minus. But then this is resistor. We need to multiply it by the current to get it, right? So I'll have 4I3. Good. And then now let's move on to this E3 here. And here the loop entering from the positive terminal. So I will have positive sign. So plus, and the voltage here is 80. Good. And now for the last component, we have this 3 kilo ohm and the loop entering from the positive terminal. So we will have plus there, and we have 3 kilo ohm. And then to get the voltage, we multiply it by the current, which is I2. Good. And all of that will equal to 0. And then what else that we can do? I think we will have 3I2. Okay, 3I2, and then minus 4I3, and minus 60 plus 80, that will be 20. And we move this 20 to the right hand side. So I'll have minus 20. Good. And if you see here, we have two equations with two variables, which equation number 1 and equation number 2. We should be able to solve them using linear algebra. So the next step will be solve 1 and 2. But then the fastest way to do that is by using calculator. Let's solve that. Let's set this up here. And equation solver is number 5. And we will have two variables, which is number 1. And then we can enter this. So we'll have minus 5. And then minus 2. And then that will equal to 10. Good. And then we will have 3. And then minus 4. And then minus 20. So we will have the value of I1 here. I mean I2 here. I2 is minus 3.08. Okay, so we'll have I2. That will be what? Minus 3.08. Okay, minus 3.08. And the unit here will be in milliampere. And what is I3? I3 here is the Y value, right? So we will have, where is my calculator? Okay, that will be 2.69. Okay, so we have 2.69 milliampere. And from here we can calculate I1, right? So because I1 is minus I2 minus I3. Okay, minus A2, that will cancel out this sign. So we will have 3.08. Okay, so we have 3.08. And then minus 2.69. And that will be 0.39. Okay, so I will have I1 is equal to 0.39 milliampere. Good. And then the question also asking us, okay, so this is the answer for question A, right? So I1 is the current that pass through this, I2 is the current that pass through this, and I3 is the current that pass through this resistor. So we have answered all the question, right, for question A. And for question B, let's find the potential difference between point C and F. Okay, here now let's answer question B. What is the potential difference between C and F? Okay, so we are asked for VCF. Maybe let's use this node here as intermediate. So A, B, C, D, E, F. Let's name this as G, right? So VCF is just VCG plus VGF, right? So we have VGF. Good. And then what is it? VCG is 64. We know it, right? So we'll have 60. And then plus VGF. So we will need to find out the I from G to F, right? Multiplied by this 3 kilo ohm, right? But we know that I2, but I2 is from F to G. So we will have this here. So I have 60. And then this one will be minus the I from F to G, right? And then multiplied by 3. But F to G is just I2, right? So we will have 60 minus, and then we'll have minus 3.08, then multiplied by 3. So we will have 60 plus 3.08, then multiplied by 3. And I think we can just leave it into calculator. 60 plus 3.08 multiplied by 3. And that will be 69.24. So I'll have 69.24. And the unit here will be in volt. So that is the potential difference between C and F. Okay, let's highlight that. And I think that's all for this problem. Thank you for watching and see you in the next video. Bye bye.